So, hi everyone. This is the obo-academy. Thank you for joining. My name is Sabrina, and today we will do, and of course I'm reopening a million. Here we are, Windows. Today we are going back to the basics. So it's the lesson about how to contribute to obo-ontologies. And thank you, Sarah, for putting the link in the chat. This is a course that we already had a long time ago. We are doing it again. So especially if you're new to ontology, if you just joined a new ontology group, and you don't know what to do with all those buttons, hopefully this is gonna help you. And if you're looking at the recording later, feel free to shoot us a message on email. Everything is really well explained in here, so you can follow along or read later or read before, and you can watch this recording. And if you still have questions, feel free to reach one of us. Okay, so let's have all the windows open here. Okay, so in order to do this course, these are the prerequisites. I think I sent that in a message. So you need to have a GitHub account and install the GitHub desktop. This will make your life much better, but then also like you cannot do anything without a GitHub account. Let's face it. Also install Protege, which will allow you to look at the ontology, and make sure you install the reasoner, the ELK 0.5 reasoner, so that you can reason on your ontology. So all of those links are here. If any of you have done that and had some problem, please say something now or later. And okay. And feel free to unmute and stop me, because I will not see the the chat. Okay, so if we have all of these, we're ready to go. Feel free to follow at the same time as I'm gonna do things. You're welcome to try with the same ontology as I do, or you can do your own ontology and then stop me if you have any questions. So what are we going to do today? Today we are going to look at, as I said, we are going back to the basics. So we're going to look at the repository for ontologies in GitHub. We're going to figure out how to look at an ontology on your own machine, and then how to make changes to the ontologies, because our job is to review ontologies and make changes to it. And then so how to make changes and how to submit those changes. It looks scary, it is not. And also, I'm going to say it a million times, there are so many checks in the whole workflow that you cannot break anything. And if you do, then you can just go back. So really, do not feel scared about doing anything at all. It's all safe and it's all okay. All right, so let's go to here. I'll put it in the chat. This is the GitHub repository for the Mondo ontology, the Mondo disease ontology. Pretty much all the ontologies look the same. If you go on GitHub, they all look the same. This is the front page. This is the main page for Pato. pick your ontology and go and visit the GitHub repository. It all looks the same. So the GitHub repository basically has everything that you need for the ontology. So it has the ontology itself, but then it also has everything that you need to construct your ontology. It has documentations, it has reports, it has everything you need for the ontology. If you look here, so we're here on the quote unquote homepage code. If you look here, issues, this is where you're going to find all the issues. Issues are basically all the things that needs to be done to update the ontology or make changes. Very often those issues are related to the ontology itself. So it could be something like create a new term, change typos. I found this error in the ontology, please repair it. But then sometimes it can also be something more technical. So anything that needs to be done, you will see it here in this on this page. And you can see those colorful little labels. These labels, depending on your ontology, these will change, but very often there is labels that says good first, where is it? Good first issue. And these are really good for people who are beginners. So, and I cannot, oh, here, good first issue. So pretty much any ontology, if you want to participate, you can just go in, pick an issue, work on it. As I said, if you don't know what you're doing and you have problem, as long you cannot break anything. So just go and try. And I'm saying that because I was really scared of doing things, and really, it's all good. Another tab here that I wanna point out is the pull request tab. This is where all your pull requests will be. We will talk about it, about what a pull request is in a minute, or a little bit more than a minute. And this is basically where all the changes that you're submitting will fall. And we'll talk about that workflow later. Okay, so this is your repository. Let's go back to code. If you're following along and I'm going too fast, please stop me, because now we're gonna start doing things. So I want to make, first thing, I want to look at the ontology on my machine. First things we are going to do is to make a copy of this whole repository onto the machine, and then open the ontology on the machine. The way to do that is, let's make sure that you have your GitHub desktop open. So I always keep it in the corner of my screen here. The GitHub desktop pretty much looks the same as, has the same things as the GitHub online. You have here the repository. As you can see, I have a few of those. And then those things, we'll talk about it. So what we want to do, we want to copy the repository. If you're looking at Mondo, do it with Mondo. I will do it with something else because I already have Mondo on my machine. So we are on this page, code. Click here on code, and you can see that it tells you you can clone it. It has a bunch of things. Path of least resistance, easy thing to do. Click on open with GitHub desktop. So if you're doing this, I will do this for payload. Same things, as I said, all repository looks the same. I click on code, open with GitHub desktop. It asks me, hopefully you can see it. Sometimes the windows don't show us. It asks me if I really want GitHub desktop to open it. Yes, open with GitHub desktop. And you can see here, hopefully you can see a pop-up window that basically tells you clone the repository. It has already put everything it needs. And then it will put this repository on your machine, there is the default is, at least for me, in the document, and the document has a GitHub folder. You can change that. It's up to you. I didn't, because it was easier. I was lazy. And then when you're happy with where it goes, click on clone. It's cloning. Depending on the repository that you're cloning, it can take a long time. And this one was pretty quick. But if you're doing it at the same time as I am doing, if you're doing cloning the mother repository, I don't know how long it's going to take. Sometimes it can take a long time. I don't know if long time means hours, but you know, if you think about, like, if you have gigantic ontologies, that of course it's going to take longer. Before we do anything, I'm going to continue talking, but before we move on, and make sure that if you're following along, you have everything, your repo is cloned. So if you look at your machine, this is, you have a glimpse in my computer's life here. In my documents, there I have a folder for GitHub. This folder, if you open it, has all the repository that I have cloned. Here I have Pato, which I just cloned in front of you right now. And the one that you are cloning now, hopefully, is Mondo. And if you can see, it has everything. So let's go back here to GitHub. I showed you earlier that GitHub here has all the files and all the folders that are needed for the ontology. All of those folders are here on my machine now. So the one that you will always need to know and always need to find is the source, src. When you open it, it has ontology, and this is where your ontology lives. I always have to find it, but it's the ontology name /edit.obo or .ow, and it's somewhere here. This one here. So this is your ontology that you will open on your machine. Before we open this ontology and we'll look at it, is there any questions or anything? Are you all following me? Are you all lost? Because if you're lost, you should tell me also. Okay, I see some thumbs up. So let's go on. So let's open the ontology. So I open Protégé. Protégé, when you open it, it can take some time. It's thinking a lot. So I already opened it before, and this is the random page. It opens, it assumes that you're going to create a new ontology every single time you're opening it. So yeah, open it. If it takes some time, it makes sense. And then you can open the ontology by going here on File, Open. I'll show you something quick here. All the recent ontology that you have open, you can just find them here. So once you work on your, I don't know, 1, 2, 3 ontologies, these are your path of least resistance. It's very fast to find the ontology you want to open. So, but we're not going to use that now because I want to show you. So you click Open, and then you will have to find on your machine where your ontology is. So remember, it is in the folders, the GitHub folder. You find the ontology that you want to have, in this case, Mondo, but all of the ontologies are pretty much the same. Find this src folder, then open the sub folders, ontology, and then find your ontology/edit.obo. And then you can open it. It's opening on, you don't see it, but it's on my other screen. It is opening. Again, it might take a little bit of time. It's gathering everything it needs to gather to open. And here we are. So this is Protégé. The Windows keeps on moving everywhere. So when you open your ontology, it always opens on this front page. It has a lot of information. Today we're not going to go into much details about this information, but if you want to know, please ask questions. We will focus on the tabs, and then here all your ontology terms you can find them in entities. Okay, when you open this, there's a lot of things depending on your ontology. Like here, where we're looking at diseases, where are diseases, it can be very overwhelming. So you open this search here. If you look at the search, click on it. And then let's look for a random disease. Let's say Alzheimer's disease. So if you can see, and the problem here is that I cannot make things bigger with Protégé. So if you don't see something, if you want me to put something in the chat, please do so, and then I'll do it. Search. When you search, you can search as you saw it happening. As I was typing, it is searching and giving you results as you need. So you don't always have to type all the full words, the full terms that you're looking for. Some things here that are very useful is that you could look for a term and asking it to be case sensitive or the whole words. I personally like, give me everything, because I never know about capital letters and this sort of things. Also, you can see here, it gives 10 results, and it tells you there's 19 more results. So depending on what you're doing, you might want to say, well, I want to see all results, open it or close it. And what it does also, it searches on every field. So here it's showing me results for display name. So when I have the ALZ in the display name, definition, synonyms, comments, label, equivalent class, subclass. So there's a lot of ways to find your terms. Let's say the first one, Alzheimer's disease 10, is what I was looking for. I double click on it and it will open the ontology wherever this term is. So if you look at the ontology, because it opened it, let's go back to the very top. It's easier to find where under this whole top organization of the ontology, it was easier to find my terms. Maybe I should know where to click and where to find it, but really I have this way, I have this options to finding things fast. So why not use it? I'm lazy. I do things as much as, like if I can do things easy in an easy way, why not? So now we have a term. Let's look around Protégé. What do we have? So every ontologies are the same, but then you might have little differences in terms of what type of information you would find. And every ontology has, every group who creates and edit ontologies have their own SOP. So there's things that we do in Mondo that maybe you would do a little bit differently, let's say in Pato, because I opened Pato earlier, or in whatever ontology you're doing. The principles are really the same, though. So on this side, let me put this here. You can, make your windows a bit bigger. You cannot make the text bigger, but you can make your windows bigger. So in this section of the window, the top right section, you have information about the term. So sorry, let's go back to the top. You have the term label, you have the ID for the terms, and you have the IRI. If you click on this little bars here, those little lines, there's also ways for you to copy these IRI or ID or display name. This is very useful, especially if you need to write an issue, or you need to click this. You need to copy these quickly. Then you have all the information about the terms. So the label, the ID, the definition. Here the definition has cross-referencing where this definition comes from. The synonyms, a different kind of synonyms. It's a different lessons. We can go to this another time. And there's, cross-reference with what other ID or what this term is in another database. A lot of information here about the term. This information is called here annotations. In this other window here, we also have more information, and this information is more about semantic. So semantic, we have the subclass of. I am assuming that everybody here has some understanding of ontology. So if I say subclass of, you understand what I mean. If you don't, please wave or say something. So subclass of here is basically your parent term. So here it says the parent is this class, and then equivalent to is basically the definition. It's like, come on, there must be one with a definition somewhere here. So here the definition for this term in semantic way is the parent as N has a mutation in this gene. So this is the part of protege where you have all your classes. We will come back to this in a minute because there's much more to discuss. But let's look around those other tabs here. That is a good thing for everybody to know. First one here, annotation properties. And yeah, these are orange. If you're a visual person, that helps. This is all the annotation properties that you can use in your ontology. We have also a lesson on annotation properties in the obo-academy, but it's things like if you want to add an annotation on the cross-reference, or if you want to add the synonyms, this is where all the type of annotations that you can add are located. And object property is the other tab here. I open it here. This is basically all the relations that you can use in order to make the semantics and those axioms. So these are, at this point, especially when you start, I think these are really like the three tabs that is good to have a good sense of what they are. Okay. Any questions before we talk about reasoning?
Sabrina, it's Katie. Just a really quick question on that annotation properties. How come some of them are bold and some of them aren't bold?
This is a great question. I don't know.
Okay.
Every time I think I figured it out, and then
I know.
I realized no.
I know the answer. It's because some
Nicole.
of them are imported from external ontologies, and some of them are just in Mondo. So I think the ones that are bold are just in Mondo, and then the other ones are imported from the information artifact ontology, IAO. Although I don't know why, like, we have a database reference that's only in Mondo, but I believe that's the reason. If you hover over them,
this one doesn't seem it's in Mondo just based on the
Oh.
name.
I think it's bold if there is one axiom in the ontology that has been that is about this entity. And probably this is because we're using obo format. You can hover over the two labels right now just so that you see this. You can see probably the first one will be in Mondo and the second one will come from the OMO import or the CL import in this case. So because we have a label in the obo file, Protege renders it with bold. That's the meaning of bold, that there's one axiom about it.
Okay. Thank you for asking, Katie. Because every time I'm like, why is it? And then I'm okay. Well, thank you, Nico and Nicole. Any other questions before we move on?
Yes, Sabrina, can you hear me?
Yes. Yes.
Okay. When you talk about equivalent classes, so for example, why does Alzheimer's disease 18, why doesn't it have an equivalent class, but 17 and 16, for example, don't, like?
So
what's the difference?
Yeah. So it depends really on whether, so an equivalent class is basically you making a definition based on semantic. In this case, we knew exactly that the 19 is the type of Alzheimer's disease that is due to a mutation in this particular gene. In the case of 16, all we know about that gene, that disease, is that it is due to a mutation somewhere, but it is not clear that indeed it's a mutation in a particular gene. Here, what we say, the definition is it's associated with a risk allele, but it is not good enough to say this gene, this disease is 100% all the time due to a mutation in this gene. So in this case, we didn't have enough information to create an equivalent class that says Alzheimer's disease 16 is this Alzheimer with this exact mutation in the gene.
Okay, so it's something that's determined by the ontology editor, really.
Yes, yes. And by the ontology editor, and it's based on whatever information you have, because we need to remember, and I think there's a lesson about that all the axioms that exist here has to be correct in 100% of the cases for whatever term you're using. Okay. And in this case, we couldn't tell that. So yes, definitely is ontology editors based on whatever information that you have.
Okay, thanks.
Any other question? Okay, let's talk about reasoning. So let's go and let's find, hopefully that's the right examples. You will never know that I look for examples. I'm finding everything as it goes. So shingle, I look for shingles, and I could see that shingle is in the definition of those two terms. It is also found as a synonym for herpes zoster. So I'm just gonna go for this one because that's the one oh, that's the one I wanted to show you. So this term has an equivalent. It has a lot of subclasses, blah, blah, blah. So what we're going to do is run the reasoner, and I'll tell you in a moment why we want to do that. So in order to do this, you go reasoner, pick your reasoner. Here we're going to use ELK 0.5, and then start reasoner. And sometimes it takes a little bit of time. There's different type of reasoners. We are using the ELK one because in most of the ontologies in OBO, that reasoner is good enough. Depending on which reasoner you're using, it might look for things that they're more specific, and really we don't need that. And you know, if it looks for things that are more specific, it takes longer. If you don't need it, don't use it. So what the reasoner does basically is that it will look at all of those subclasses and all of those equivalent, and then it's going to tell you, well, actually, there's all those other relations that you could have, that this term could have. So you could imagine creating an ontology that just have terms, like a flat list of terms that does not have, you know, parents or such things, and then have only the subclasses of, and then you run the reasoner, and all your classification happens miraculously. It's not miracle, it's a reasoner, but this is what the reasoner does. And we'll leave it there because we can go into more complicated discussions, but this is not the point. So when I run the reasoner, you see this little yellow that happened. And what it tells you, if I can find my, sorry, don't get sick while I'm looking for this term here. So here, when I look at this version, at this view, it is called asserted. This is my term. I told this term is, you know, a post-viral disease, blah, blah, blah. But then when I ran the reasoner, it told me actually it has other parents. It's also a disease that arises from reactivation of latent virus. It's also a skin disorder caused by infection. So all those things that I didn't tell it, it just infer. If you click here, so this is the asserted view. If you click on the inferred view, and it's going to happen, yeah, then everything is yellow. But then you can see the ontology in the format that includes all these parents and all those extra things that were inferred. When this is the view that when you look at an ontology and you're trying to question it and you're trying to figure out things who are the parents, blah, blah, blah. I really think that the inferred view is really the view that you need to look at, so that you are aware of all the parents that a term might have. So so just to make it, you know, a little bit more exciting here, if we go to this term as trisomy 16, all I told it, all I told for this term is that trisomy 16 is a trisomy that happened to affect chromosome 16. And then by running the reasoner, it was able to say, well, it is also chromosome, trisomy 16 is also a trisomy because, and then you can click here and it's gonna find an explanation here because it is equivalent to trisomy. And when you look at trisomy, so you can actually click on this and then you go, trisomy is, sorry, wrong example. It tells you it's a trisomy because it's here in the equivalent class. It also tells you that it's a chromosome 16 disorder because the definition of chromosome 16 disorder is that it's a chromosome disorder that affects chromosome 16. So the reasoner, based on this definition, was able to say, well, if trisomy 16 is a trisomy that affects chromosome 16, then I can say that it should have the parent chromosome 16 disorder, and it should also have the parent trisomy. So your reasoner is going to look at all the classifications. Sometimes this classification you didn't even think about, things that you know, we didn't realize that we were saying. Sometimes it's a good thing, sometimes it's not. So every time you make a change, try to remember to look at the inferred view, run the reasoner. If you make changes, you will have to start the synchronize the reasoner again. Because you might make a change and that change might have consequences that you were not aware of. So running the reasoner is always a good way to spot mistakes. Okay, I think I am done with the walking through Protégé and looking at different view. Is there any questions before we start making changes? What are we doing on time? Perfect. Okay. So this is, again, I said, if I'm not saying it 50 times, I will not say it once. This is a scary part, but it's not scary because there is a lot of checks that are in place that if you make a mistake, you're not going to break the whole things, and everything can, you know, you can back up of everything you're doing. So just play around and try, because really, I think trying and making mistakes and getting into those problems where you don't know what you did and you don't know how to solve it, this is really the only way to feel comfortable and do things. So we're going to change something in the ontology. All the changes are mostly here. You will find them here in the repository issue here, all the issues. Maybe it's not going to be everything in the issues. Maybe it's going to be, you know, you're working on a project and you're just like, hey, I wonder what would happen if I restructure this whole branch. So you can just do that and try it and see what happened. But, you know, I think at the beginning, most of your work will be attached to a GitHub issue. So I created some issues. They are all kind of like, here it is. The first one we're looking at. These are not 100% true. So, so when you're gonna make a change and it's like, and then if you go actually to this one here, let me send this one also. If you look at those first three issues, they're obo-academy exercise. They're kind of made, they're completely made up. But it is hard to find actual, you know, actual issues and actual changes that, you know, are true without. So anyways, roll with it, even if it doesn't make, even if biologically it doesn't make sense, please roll with it. So we also have so many so many lessons. Please take a look at them. We have lessons on how to create a good issue. very, basically the more information you can write in your issue, the better it is. This one is not really good at all. I didn't explain why I want this change. I didn't put my name. I mean, my name is here, but adding your orchid. I didn't put a reference of, this is the PMID, the resource that tells me that this is why this change should be. So let's put aside for a moment that I'm showing you something very bad, but we'll do the other lesson about how to make a good GitHub issue, and then we'll have zero excuses. Okay, blah blah blah. That's all I have to say at this point. So what we want to do, something super simple. We want to change the label from this label to this other label. So before we do anything, the way it's going to work is that we're going to make a copy of the ontology on our machine. We're going to take the latest version of the ontology. We have it on our machine. We're halfway there. So like 3/4 or even more there. So that's good. We're all set. So we'll take a copy of the ontology. We'll make changes, and then we'll put it in a package, send it to GitHub and say, these are the changes I'm proposing to the ontology. Somebody will review those changes and either say, great, that sounds great, those changes can go forward, or they will say, please make those review your work and do those extra changes, and then we can push it. So this is basically what we will do with a very I like to make comparison with other things. So that was completely not technical, but that's basically what we're doing. Okay, so we are going to our GitHub desktop. Here we picked the correct repository. Here we're gonna get Mondo. If you saw here, it like this the little wheel that turns. And here we're gonna pick a branch. So first of all, master. Master is, as its name says, is the master branch. It has all the latest, it has the latest ontology, the latest things that the curators and the editors said, this is correct, this is the latest that we should use. You should step back for a second. So you want when you make changes, you want the latest version of the ontology. So you want to go to master. And so you say, hey, master, and you click here, fetch origin. Sometimes you have things that you're fetching. In this case, we don't, because I just did it. But so you need to go to the master branch, fetch everything that is new. And now everything that is on your machine is up to date. That's good. Second, we don't want to be making changes to the main branch directly, because this is very dangerous. We don't want to be, doing changes that we're not sure that they're going to be correct, and then pushing it into master. This is not what we do in this world. So we're going to create a new branch. We click here. We name that branch whatever we want. The best way really to follow your work, and especially if you go back later, is to give it the name. We give it the name issue / and then the name, the number of your issue. So this one here, you can call it whatever, like Sabrina 123. After, I would say, even 6 months, you will be like so overwhelmed. So I think that naming your branch based on the issue is really what is going to be the most helpful. And then create branch. Do you want to create a branch? Yeah. Create a branch. And then things change here. It tells you, are you ready to publish? We didn't do anything, so no, we're not ready to publish. If you forget to create a branch, you still have a chance later to do that. So we will see later, we will, in here, we will see the changes that we make to the ontology. And then at that point, we can realize, oh, I'm not on the correct branch. You can create the branch and then move your changes to your new branch. So if we have time, we can do that. So I can show you how it works. So if you forget to create your branch, you're fine. You have another opportunity later. Then we will open Protégé here. I already have it open. If you make changes and then you want to make different changes because the ontology behind will change, you might have to reopen it. So in this case, because I did nothing, I will not. But again, if we have time to do a second exercise, I will show you. Here, I know that I am on a branch because here in the corner, even in smaller font here, it tells you git issue 5548. That is basically telling you you're looking at the ontology on this branch. So if I make a lot of changes, this branch will look different than the master branch. Hopefully I'm not confusing anybody here. So what are we supposed to do here? This is a term. Hopefully you're all doing it at the same time as I am. It is a bad issue. I don't even know what the Mondo ID is. Well, no problem. We can just search it. So let's copy this term name and let's search for it. It found it as a display and as a label. And yeah, it does look like it's the correct one. So for this tutorial, we're just going to change the label and that's it. Depending on where you are, which ontology you're working on, there's SOP around it. So in this case, for Mondo, I would probably not just delete the name and it's gone forever. I would probably make this name a synonym so that if somebody searched for it, somebody would be still able to find it. So be aware that what I'm showing you is not proper SOP. We're just making changes kind of like for the sake of making changes and for the sake of learning how the process works. But make sure you follow the SOP from your ontology. So we want to change the label here. So I click on label. There's different ways of doing it. You can click here on the little round button, edit. But if you double click on this, it opens, the window opens. So, and it opened twice. No, good. We're good. So here, this is how you, every boxes, here I call them boxes. Every time you open them, they open in a little window where they tell you what annotation property you're looking at. So in this case, we are looking at the label, and this is what the label is. There's a lot of other options of, you know, what you can add, what you can choose. You can choose IRI. This will depend on what sort of information you're adding, what sort of annotation you're adding. Again, this is another lesson. So for today, we're just going to change this, but there's so much more to learn about that. So I said the label should be this. Okay. And I did open it twice. So you can see here, we changed the label. It's all good. We're happy. Let's save it. You can save it here. Whatever Command S also works. I don't know if you're in a window, what it is. And then here we go back to the GitHub desktop and you can see the difference. So you can see what changes you have made to your ontology. Here, it tells you here, the changes was in this file, the Mondo edit.obo, great. That's the file I wanted to change. Also great, I didn't change any other file. So phew, we're good. And then you can see there's different views. I don't even know. Yeah. So you can look at the unified view or the split view. It is this little wheel here. I like the split view because I see what is changed, but use whatever you like the best. And so here we can see the part of the file that was changed. So the file, we looked at it in Protege where it's all nice and this all those boxes. The actual file is basically each term has a block of information. So here we have this term and the name for this term was this, and it's in red. So we deleted that and we replaced it with this thing that is in green. If we're happy, we can go on. If we're not happy, we can go back to Protege, make more changes. If you're really not happy with anything that happened because you tried something and it really didn't work and nothing is works, you can go back here to your main files and then you click write and you can discard charges. So we can go back to square one if we really want to, or if you made a change in a different file that you didn't want to make a change, like this, you can change things however you want. Okay, we're happy with that. So we will, as I mentioned earlier, let's go back to this image. We'll bundle those changes and send them to the repo and say, I think I did a change, please help me. So here in this lower corner, we have to give it a title. So the title is the title for your PR. Be as explicit as you can, because then everybody knows what you did. So here, I would say change name for Mondo, whatever, 001526. And then you can put a description. So in the description, it's always good to refer to the issue you're working on, because then somebody who's reviewing your PR can go back to the issue and say, what was it, what is it supposed to do? So we'll refer to the issue with the hashtag, and then you write the name of the issue. Yes, this is the one. And then depending on what you want to do, you could say that this issue addresses, this PR addresses the issue. If you use the word fixes or closes, when the PR is accepted, it will close the original issue. So there's more details in the documentation. Feel free to look into that. It's very useful, because then you don't need to go back. It's just like, okay, I'm done. So here we're ready with everything. Commit to issue, blah, blah, blah. And then it tells you, are you ready to publish your branch? And yes, you click publish branch. What it does, it bundles everything, get it ready to submit the PR. And then you click create PR. It opens yet another window in Protege. So here we are. All our changes are here, and we're ready to say, I am ready for somebody to review it. Click pull request. And so it creates a pull request. It also starts checking that the changes make sense. So if you do something very bad, the checks will tell you you did something wrong. And then you can go, I have an example somewhere here. Let me show you very quickly. here I purposely did something wrong, and then it tells you everything is red. It's like, you have a problem, the checks failed, and then you can click here and see what failed. You will also get an email, so so you will know. Here, then what's going to happen is that somebody will look at it and review it. You can also look at it yourself. If you click here, file changes, then you can see what changes were made. And so somebody can come and look and then say, I don't think that's the correct thing. Like, nope, try again. And then you will get the information telling you, well, you need to make changes to your PR. And then when everything is done and everything is accepted, then you can push it, and those changes will be pushed to master, and then they will be part of the final ontology. That's the process. Any questions? I know we run through this a little bit, but
Sabrina,
yes.
how do you undo changes once you've committed and published your branch?
I don't know if you can undo changes. So what? Let's say here, I go back to master and I fetch master, and then I need to make changes to the branch I just created. And let's say, oh, I forgot a period, or I forgot like a typo or something. You can go back here, go back to the branch that you want to make changes. So in this case, this is the one that we just created. Fetch origin, so get all the changes that are on this branch and get them back into your machine, and then you can go and make more changes to what you had done. So it's like changing your changes. I don't think that you can, let's imagine you have like, see, and it tells you, oh, you change the ontology, you want to reload it. If you made changes and you, let's say, have like 10 different diff here, and you say, I don't want this one particular one, remove it. I don't know that you can. Nicole, do you know that you can undo a particular change? Every time that happened, I just went back and either redo it. If it's very bad, I just start from scratch. But
you can reverse the commit, right, Nico? If you go back to GitHub.
Yes.
That's trying to remember how to do it.
No, you can do it actually in GitHub Desktop as well. You can just click on the history there. So, but one thing to remember for the question of undoing changes. So in Git, you don't really undo anything ever. You always add stuff. But what you can do is, as Nicole says, is you can go and say, okay, this commit here was somehow bad for me. So you can right click on the commit. Yeah, and then just say revert changes in this commit.
Okay, this is what I was looking for. Okay.
Just look at what is happening now, and then click on say on the history, and see that you have now created a new commit, a completely new one that is independent of the one that you previously had, which basically is just the opposite of the previous commit you made. So this is how you undo stuff, like you revert a commit by adding a new commit, but both of these commit will still be in the commit history. And the only way, I guess that you might get rid of them if you wanted to, would be if you before you merge your pull request is to use a different strategy for merging than the normal strategy, which is just to merge all of the commits into the master branch. But you could also use something like a merge commit, or what's this other thing called? I forgot again. Where all of your commits on the branch will be put into a single commit, and then you will obviously not see your experimental intermediate commits anymore. But that's all. So that's how you undo stuff in Git.
Okay.
Could someone write a how-to guide for that? Because that's really handy, and sounds like we don't all remember how to do that.
I'm aware we past the time. I think anyways, this lesson is a two-parter, so we can pick it up whenever. If you want to play around and look at things, feel free to look at the Mondo things, that is the Mondo issues there, and feel free to do things to you know, working on those obo-academy exercises. They're silly, but you know, it's good to try them. So anything before we go? I'm very sorry, we're past time.